Okay, so thanks everybody. This is the first in a new series of Oracle NoSQL office hours. So we're going to talk about this demo that Dario and I built in the last few months. And I realized, so it's a reference architecture built on Oracle NoSQL database, but really more importantly, it's really built on OCI services as well. So we could not have done this without all of the OCI services that we used. And we're going to talk about that as we go through this demo. But first off, I want to give people a few minutes to just simply bring up a browser on your mobile device and go to ndcsdemo.com. Or if you have a QR code scanner, just scan that QR code. And it doesn't matter where you are currently in the world, it will quickly bring up a little application that should look like this, if you can see my mobile. And if you click the track your baggage control, you'll see within predictable latency, it's under a second, typically no matter where you are in the world, it will actually demo this user experience of, hey, I'd like to actually know where my bags are on the journey if I'm taking a flight. You can also click the hamburger menu, and really the only link that is enabled there, or the only menu item, is to track your bags. But the point is, it's an interesting real-world application, and we're going to take you through in this presentation several things, interesting things about how we built this thing, how we actually are able to get this sort of predictable latency and user experience no matter where in the world anybody is using this application. So since a couple of people are joining, I'm just going to leave this slide up for like another 30 seconds just so people can actually look at the demo quickly. So for those of you who just joined, on your mobile device, just bring up a browser and go to ndcsdemo.com or scan that QR code, and you'll bring up the demo. So it's pretty simple. And the demo shows basically just a one-click action, track your baggage. Okay, so we'll talk about why we actually chose this use case. Unfortunately, we originally decided to focus on this use case before COVID. So it was a really compelling use case, and we'll tell you why up until the airline industry shut down. But hopefully that'll be coming back soon. We're going to tell you exactly how we built this thing, all the different components, and then we're also going to talk you through which of the OCI services we used and why those things are so compelling to build these types of modern worldwide distributed applications, geo-distributed. Okay, so why did we actually decide to do this one? So there's a number of really interesting dimensions to this little application. So number one, folks are doing this in the real world today. Go to the largest carriers out there in the world. Qantas, United, Delta, Southwest, just those in the US, British Airways, they all now have this user experience in their apps. And I think it's a result of this SITA survey, which is a company that focuses on technology in the airline industry. And in 2017, their survey indicated that 76% of all consumers taking flights wanted a way to get real-time updates on their bags as they travel through the journey. All right, and everybody's got access to an app on their smartphone, and they're connected. The other thing that makes this really, really interesting is that this really seems to be the symptom of a larger trend, and that is this. Over the last, I would say, decade, the trend has been to take the data that's been collected in the back office, right? So in the previous decade, right, in the 90s, lots and lots of applications were built to store lots and lots of data in the back office. Lots of ERP has been deployed, HCM, all kinds of apps have been deployed in the back office, and now people are getting that data out to consumers at consumer scale, right? So, right, what's the status of my order, right? Show me everything I've purchased, right, in the last 12 months. And yeah, let me actually search that list and buy it again with one click. Where's my package, right, that I ordered in its route to my house, and when can I expect that thing to arrive? So this is all, 10 years ago, this was all back office data. Now everybody now interacts with this data in real time from their phone. The final interesting dimension to the problem was when we looked at this data, and at the time we were working with Emirates Airlines before the COVID shutdown. We realized that it's not just some simple little example of JSON. It's really a fairly complex document structure. It's fairly heavily nested. It uses arrays and arrays of documents. So it does give you a good sense of how complex this data can get in the real world. And it's a really good example of how JSON is used in the real world, and a fairly complex dialect of it. So just to give you an idea of what the data looks like. So first off, as you're looking at the demo, it's all anonymized. It's all randomly generated. The names are randomly generated. The phone numbers are randomly generated. The routes are generated from open source air flight data. So it's all randomly generated data. The point here, though, is if you look at the structure, it's not some little flat structure. It's got a fair amount of nesting to it. So you can see some high-level attributes at the top, but then you quickly realize, wow, every passenger has an array of bags, right? Passenger can have more than one bag on their journey. And then every bag has information. Every bag has also a set of legs in the journey. So each flight that a bag takes along the journey has an array entry. And of course, there are actions that happen. So there's an array of actions at each one of those stops in the journey. So pretty heavily nested with, like, an array of arrays of arrays with embedded documents. So, right, not just a simple flat little fake JSON document. It actually is fairly complex. Okay, so we're going to dig into the architecture. So this is actually a very, very simple, brain dead simple application architecture. At the high level, really 3 simple components, right? I guess 4 if you include, the front end, global DNS, and OCI traffic steering. But we're gonna talk about that in a couple of slides. But really, you have the front end, global DNS and OCI traffic management. And then that gets us to, when you go to ndcsdemo.com, it gets us down to one of these regions based on our traffic steering policy. And in each region, we just simply have an OCI API gateway stood up. We have a Tomcat server that is serving up the REST interfaces for the data, and that is just connected to Oracle NoSQL Cloud Service. And then we have an Apache web server HTTPD that is just serving up the static images and acting as a pass-through for the any of the calls coming into the REST service. So it's really, really simple in terms of an architecture perspective. And we're going to open this up for questions when we're done with the slides. So again, just to show you how simple this was to build, we have a single table in each region. And the schema is really straightforward, right? You can see right there, we have 4 columns in this table. So there's a ticket number, there's the name of the passenger, there's the reservation code for the actual reservation that was booked. And then there's a JSON content. All of the JSON we just looked at is sitting in that JSON content. And again, we have a servlet running to serve the UI requests and Apache HTTPD to serve up the images. Okay, so now we're going to get into some of the services that we used on Oracle OCI that we really felt were quite good and quite compelling. So let's see. Okay, so this is an interesting one, and we start here because really, when we started working on this, we started working on two different pieces of this demo. There was the back end piece to build the REST interfaces and to get to turn that into JSON data to send back to the UI. And then there was all the UI work. And we quickly realized that we needed a contract to agree on. And we found that there is Oracle Apiary, right? So Oracle acquired this company called Apiary. And it's a really, really nice cloud utility that allows the collaboration between two developers, wherever you are in the world. It allows you to really easily collaborate on a contract between any two components. So the contract is specified as a REST API. So you go to Oracle's Apiary and you define this API, which of course has just, the URIs you're going to contact and the methods you want to support, like putting get and what the parameters are and what the return codes look like. And two people can now independently work with this contract hosted on Oracle Apiary and just work independently. And then when you're both done, if in fact your code conforms to the contract, then the two pieces will just automatically integrate. And it's really quite a nice way to develop, and I would say 90% of the folks out there today, maybe even 100% that are developing quote APIs, they're all REST. And I don't know how many people realize that Oracle now has a really, really compelling tool for collaborating on development of REST APIs, and it is called Apiary. So we found that super, super helpful. Right?
Just a comment, Dave.
Yes.
So if you want to see the API documentation, use the URL provided in the chat. As you can see here, you can be able to download to see the YAML Swagger file. And of course, you can do a call to each endpoint using the console. So you can go to the production server or a mock server. All examples are provided. For your information, when using production, you will use the gateway in Frankfurt. If you need to use a gateway in another region, please let us know. And if something is not working or if you need help, we are here to help you.
Absolutely. Thanks, Daria. Okay, and just to show you what this looks like, so really quite simple. As a developer, you just put the definition of what your payload needs to look like in this. What you're looking at is called a YAML format. It's really simple though. You can see that this bag info object, has a bunch of properties, right? The tag number, the full name, the name of the passenger, the ticket number. These are things we just saw that are sitting in the Oracle NoSQL table. And then it talks about having like an array of routing information. And then it talks about having an array of actions. So this definition here actually turns into JSON. And in effect, a REST API payload definition like this is really defining JSON. So when you hear, you've all heard how popular JSON is, and my guess is one of the big factors in its popularity is that, right, as you're working with these UI, or REST API definitions, it's really all being done in JSON, right? This definition here is defining a JSON object. Okay, so a little example of the small amount of code to actually get your hands on that data in NoSQL. So the first example we have here is a piece of code that is retrieving all of the bag info or array of bag infos given a a ticket number from a customer. And you can see it's whatever, 4 lines of code. We just create what's called a GET request. We set the key to the ticket number. We set the table name to the table that we have our data in. For our case, it's called baggage demo data. We use our connection to the NoSQL Cloud Service, and we make a GET call, and we're done. We return the results of that GET call, and that's it. Writing a record, pretty simple as well, right? We kind of do the same thing. We create this map value object. We put the attributes of that into the different columns, right? And then on the last line, we're just taking the JSON content as we're getting it, right? And we're calling a convenience method, dot put from JSON. And then we're creating a put request, just like we did above for a GET request. And we just call the put API in NoSQL, and we're done. So pretty simple, small amount of code to read a record or to write a record. Now, on the JSON side, right, it gets actually a little more interesting, right? Because as we talked about a minute ago, what you really need to do is materialize JSON for the user interface, right? Right. Everything's REST. REST describes the format of the payload that the UI is going to need, and it's really describing JSON. So how do we do this in NoSQL? It's really, really easy. So we just use a simple JSON constructor. You can see that the select statement opens up a curly brace, and it's constructing a JSON document with the full name, the ticket, and the gender of the passenger in this example. And then we have actually projected out a fragment of the JSON as it's sitting in the database, and we've said, hey, only give me the bag info array for those bags whose tag number is a specific tag number that I'm interested in. So it's a really simple yet powerful way to slice through JSON arrays. And so one of the things that we talked about a few slides ago was, hey, this is kind of real world complex data. In the real world, you have these, arrays of documents and more arrays. So the real world tends to be fairly heavily nested. And this gives you an example of how simple it is to just slice through an array and return a fragment of it to the front end. And then finally, on that where clause, again, you want to be able to just say, hey, give me any, part of a JSON array that, has the tag number in this example as this parameter. So the first piece up top, we're actually, projecting out a fragment based on a condition. And then we are at the bottom piece, we are restricting that same JSON document on the same tag number restriction, right? Does that make sense to people? Hopefully it does. Okay, so how did we actually do this? What OCI services did we use, and why were they so compelling? And how did we actually get worldwide geo-distributed low latency response time? The first thing we used was the OCI API gateway, which is really nice and convenient and gives you a way to set up really an interface on top of your REST server, and it allows really quick experimentation and support and ongoing maintenance of your backend services. So you basically just set up this gateway, and it traps all of the incoming HTTP, and you can just configure it to forward that on to your REST server. So it really gives you a nice way to isolate the backend from the front end. So we use that in every single region. We use this thing called OCI, Geo-Steering Traffic Management. And so how did we actually, this is how we actually provide low latency or local latency along with NoSQL database anywhere in the world. So we start with NoSQL, which is really focused on this whole like consumer scale experience, simple queries returned in predictable single-digit millisecond latencies. And then you go up the stack, and then you need some sort of geo-steering that says, okay, hey, well, I got my low latency from the NoSQL access. That's good. So what I'll do is I'll set up a NoSQL table in 5 regions in the world. And what we've done in this demo is we have a NoSQL table in US West, US East, South America. We have one in India. We have one in Tokyo. And I think, oh, we have
Frankfurt, Dave.
Frankfurt as well, sorry. Yeah. And basically, right, the idea here is you've set up your NoSQL data in different regions, and then this really nice feature in OCI basically says, okay, I'm going to give you the ability to specify routing rules at the DNS level. So when you actually make a request to ndcsdemo.com, global DNS will find the Oracle name server, right? And that's how we've configured it that way. And the Oracle name server will actually use the location of the DNS server that is calling it, which is going to be close to you. And it will use this geo-steering traffic management to route the REST call, the API request, to the physically closest data center to the name server, essentially the physically closest data center to your device, wherever you're making that request. And so, within a few clicks in OCI, and, maybe half a day's worth of reading, we were able to set up a worldwide application that gives, predictable low latency across the world. It was really quite easy to use and quite powerful. And we tested this by, trace routing these calls and proved that as Dario was playing with the app, his requests were being routed to Frankfurt. And as I was playing with the app, my requests were being routed to the Phoenix data center in the western part of the US. So really nice stuff, allows you to build these, geo-distributed applications really quite easily. And then we also, and Dario is going to talk about this, we use this Visual Builder cloud service that allows you to write fairly sophisticated UIs in a low-code way that will run either on an iOS device or an Android device or a browser anywhere. And as you might have seen, we actually install this as what's called a progressive application. Since, right, we don't have the ability to upload a native iOS app to the Apple App Store or Google Play, right? It's a demo. I don't think they would allow us to package and upload into their stores. Okay, so Dario is going to take you through a little bit how we did the user interface.
Just before to start, there is 2 applications. This is a mobile application if you use a mobile, but you have also an application, a web application. And in this case, you are not an end user, you are people of the staff. So you can do the two things using the same URL, okay? So just before to explain this slide, let me talk about the most interesting point about this demo, the story and the challenge behind. So after a big brainstorming about how to promote NoSQL in a lobby hotel at Toulouse, they've accepted my challenge, build a full demo backend and frontend. That is a real challenge for us because Dave and I, we are from backend. All of knowledge is in backend, not in frontend. So Dave will be in charge to find the subject of the demo and in charge of the backend and data model. From my side, I will be in charge of the front end. The choice of the front end framework was me. So we have discussion about React, Ionic, Angular, Vue. So at the end of the day, I choose Object, and of course, I choose Visual Build. I was also in charge to choose the tools, Apiary, API Gateway, but the API design was owned by Dave. He knows the data, not me. That is an important point because I learned about how the data is stored just doing the dry run for this demo. I was not aware about how they was built or drive your backend. Okay. Another interesting point for this demo was that the UI design was outsourced to a marketing team. So if you see in the left, this is not my UI design. I am not good for do this. So the API and the UI design teams were not done by the same team. And the most important point here, the API design was not influenced by the front-end team. So I have no influence about how they will show the information and how they will store the information. So the layout, the colors, the airline names was provided. We have a very good interesting history about the airline's name. The way and information to show initial screens was delivered by the marketing team, not by Dave or I. So the acceptance test was done by the marketing team. They accept some few little difference between the design and the result. So we were different teams doing their own choice. As you can see here in the slide, one of the challenges, this is not a simple master detail Visual Builder Cloud solution application. We are not calling one API to build the master and then another API for the detail. As you can see here, I am doing a mashup from multiple calls. So we are calling multiple API in parallel, as you can see here in this workflow. And doing this, I am able to retrieve the information needed for the script. As you can see here in the right button, I am also doing some loops. So I developed this using a workflow inside Visual Builder Cloud Service. So that shows the power of the tool. It was very interesting because when I did my first hands-on lab, I just say it's just a simple master detail. So we are not aware about the power of this tool. For CSS, another style, and learn about how to write some code to modify the look and feel from the standard Visual Builder application. So I can say low code doesn't mean not code. And I also use object operator if and loop. This is because our API are returning a lot of arrays and not only fields with a simple type. So really interesting experience, and the conclusion, Visual Builder Cloud Service and Object are very powerful tools. I think that we have no regrets in our choice. So that is for this slide. Dave, please, next one. We did other tests. If you see in the chat, I built also a digital assistant. So in the bottom right of the screen, you can access to the chatbot. This is a digital assistant. This is a very simple conversational design. So in this case, wherever you say, hello, where is my baggage? The bot will choose a random customer and show the trip and current bag information. In the same way as we are doing in the mobile application. The difference is here is I decide to show one by one the information in the route instead to show all, because most of people are interested just in the last step. So in the mobile application and in the digital assistants, I'm not doing exactly the same thing. So you can click and done to stop the flow, or you can click in more action if you want to see the back information to the previous step in the route. So you can activate also the zone. It's very nice. Anyway, in this case, I am just using the web channel for Visual Builder Cloud application. I just want to try with using Slack, but no time, okay? For information, this is currently deployed only in my tenancy in Frankfurt, but I also did a test in Austin because I am not using the tenancy from Dave. I am using the French sales engineer tenancy, but I can deploy in other tenancies. We just need a port and configure to indicate the good gateway, even if you are accessing the data in the Dave tenancies. You will be in the same region. So if you want to use this tutorial, just let me know, and I can provide the export file to do this. Another point, the gateway was not already included in the Geo-Steering configuration, so we need to provide the API for the good region, okay? Another test that we did is using Oracle Management Cloud Service. So we are monitoring the geo-distributed application for multiple points of presence in the world. So when we are calling the DNS entry, the idea is to validate that we have the same latency wherever you are in the world. But we are also want to monitor a provide URL for a specific location, so a region from multiple point of presence, just to see the change in the latency, to show our customer how useful is our application. All of these tests, we have a Selenium test, and we have also a simple REST test to validate the API code. So we are validating the application as a whole, and we are also validating each component. As I said, the decision about the backend was their responsibility, but I did some other tests. So for example, I use Oracle Function as a backend. In my case, I prefer to use Node.js instead of Java. And of course, behind this, the gateway. So I learned how to easily move from one to another, HTTP backend to Oracle Function. I did also some tests using GraphQL. That is a new query language for the API, an alternative to REST and SOAP. In fact, just for information, I already showed the application to colleagues inside and outside Oracle. So I am currently working to show this demo in the French Innovation Hub events. So we receive a lot of feedback, and we are able to enrich the demo as you want. So please provide your feedback and your expectation. Yes, next slide. Okay. So just let me finish to showing the dev architecture, because in the previous slide we showed the deployment architecture. As you can see here, we have the digital assistant. Let me just a little moment, please. So we have the digital assistant here. We have Visual Builder Cloud Service here. We have all the stuff about DNS and Geo-Steering. We did some tests using also WAF, but as you know, in Visual Builder Cloud Service, when it is installed in managed instance, we have also WAF, so we need to configure this because we decide to use our own VMs. So as you can see here, we have Oracle Monitoring Cloud Service. We try to use Oracle Integration Cloud. So the idea is instead to do the mashup in the application, do the mashup using Integration Cloud Service. And as I said, you use also FN. So just for information, though, we have the application here. And as you can see here, we deploy the application using VMs, okay? So I create a CI/CD pipeline that will build the Visual Builder Cloud Service artifact on just as zip files after optimizing using run commands. And I also did this test using Developer Cloud Services. We are copying the artifact from the repository, to each VM, the VM with a very simple HTTP server configured as already showed, okay? So finally, we are just unzipping the artifact and executing a simple command to modify the XML file in order to provide a good gateway to use. And we are doing this in all regions that we decide to deploy, okay? So don't hesitate to contact us if we need more information. You want to know more about this demo, I can do a deep dive in each topic. we can schedule a one-to-one or one-to-many meeting if you are interested for some of those components in the back end and in the front end. Okay, Dave, I finish.
All right, thanks, Dario. Just a quick point. Yes, I'll actually share these slides. I'll upload them to Oradocs along with the video and send that out for anybody that needs to take a look. So we'll just leave you with a couple of more slides and then open it up for questions. But I wanted people to just get a sense of where things are with Oracle NoSQL these days in terms of the numbers, right? We could talk about how cool it is and how interesting it is and the low latency and all that stuff, but the numbers I think are more telling than anything else. So between September of 2019 and this year, we actually had 3,300 downloads of the licensed version of NoSQL. And basically what that is it's people that are choosing to use extra RDBMS licenses that they have lying around or that they haven't used on some cores to run the licensed version of Oracle NoSQL. So people are voting with their licenses and choosing to use some NoSQL out there. We had over 5,000 downloads of the open source version of the NoSQL product. So we continue to see downloads, on the order of multiple thousands of the product every year. So these are numbers that were similar to last year's numbers. Between 2018 and 2019, we had a very similar number of downloads on the order of, I think, 9,000 last year, something like that. The cloud service, the fully managed cloud service went live back on March 1st. So 6 months ago. And you're looking at the graph of the growth. Now you're looking at week over week, which is it's a hard growth to look at. It looks fairly flat, but if we were to look at this quarter over quarter, which of course we only have 2 data points, the growth would look a bit different. But really the takeaway here is that 300 tenancies have shown up 300 tenants have shown up to use the service in 6 months of being live. We've already sold out of about 47% of our worldwide capacity. So it's interesting. The next interesting data point is that to date, we have had over 1,200 downloads of our NoSQL developer plugin. So developers, use these IDEs. IntelliJ is one of the most popular ones. They also use Eclipse, and we have an Eclipse plugin. But just on that one IntelliJ plugin alone, that's only been out there for less than a year now. We've had 1,200 developers choose to download that, and we get a rating of 4.4 out of 5 stars. So the developers are speaking. They are finding the functionality interesting and compelling, and they're actually downloading it and using it. Okay, so what are the takeaways here? And then we'll open it up for questions, right? We have a single-click demo right now that you can use on your mobile device anywhere in the world that will showcase, right, a real business use case and why it's interesting from a NoSQL perspective, right? Back office data, you want to get it out to consumer scale. You don't, you want to offload that query from the relational store running in the back end. And the easiest and quickest way to do that is using OCI. And it gives you a rich, development experience to really do a geo-distributed application and get it out there in the world, right? And get it out there fairly quickly. Visual Builder, pretty compelling to actually, do a low-code application. So we've shown how the whole package, Oracle NoSQL for these kinds of use cases, which are getting popular, along with Oracle OCI and the services that we offer are pretty compelling. And NoSQL is actually gaining traction, right? People are using it out there. So there's a real opportunity out there for your customers that are looking in this area for, reaching the consumer and doing simple, simple queries, to customize a user experience or get this data from the back office out to the consumer. It's hot, and I think you're going to find that more and more of your customers are looking to do this kind of thing. Okay, so let's open it up for questions. You can either type it in the chat or just unmute yourself, and we are open.
Question or comments? What do you think about the application? What do you think about the service that we choose? Feedback is always welcome.
Yes, yes. Questions, comments, good or bad. All right.
So for example, I see that Fernando is here. So the next step is to configure the geo tables. What is exactly the name, Dave? In NoSQL regional tables, that is the name? Dave?
What's that?
Multi-region tables, right?
Multi-region table. That is the next step for the application to have a real geo-distributed application.
Yeah, so we are currently, yes, you're right. So today, there's a question from Matt. We'll get to that in a second. But today, if you want to get your data to all the regions, it's just a single call from one location. Because our API runs over HTTP, the application would just have to make the put call into the 4 or 5 different regions for the data. Tomorrow, we will, not literally tomorrow, but next year, we will actually go live with our multi-region table feature, which will automatically replicate the data across any regions that you choose to participate as a multi-region table. So that works today on-prem. There's work to be done to get that live in the cloud service. Does that answer your question? Okay, so we have a question from Matt. What type of scalability can we get? So, yeah, so from the perspective of the NoSQL Cloud Service itself, right? We already know that we can do on a per shard basis about 100,000 reads per second, and that thing scales out linearly. And so we've done benchmarks on commodity server hardware, 16 cores, where we're getting over 1 million reads per second with a 95th percentile latency of about a millisecond and a half. So yeah, we can easily scale NoSQL out to millions of requests per second. The application itself, of course, would have to scale as well, right? Could we do it? Absolutely. So we could use OCI load balancing. So we could put a load balancer in front of all of the REST servers, scale those out horizontally. But the answer is yeah, the whole stack, all the way from the NoSQL Cloud Service up to OCI load balancing, can easily scale out, up to millions of requests per second. Absolutely.
I could say that we are also using a lot of things for scalability. We are using multiple data centers. We are using multiple point of presence, for example, for DDoS, for WAF, for things like that. We are missing, what is the name? The image is managed, the image for the application is managed in each data center locally. So we are missing this probability to use a CDN to do these kind of things. But we are scaling from multiple points of view. We are scaling because we are running in multiple data centers that allow to have a very good latency. So we are scaling in multiple ways. We are scaling using multiple data centers, using NoSQL, using load balancers, using functions, using everything that we can have from OCI.
Yeah, good point. So the other question from Matt was about, can it handle files, videos, and images? And it certainly can. Now, the question there, though, that we have really grappled with. So NoSQL is a great platform for storing things like, you know, images and large images like MPEG files along with the data. However, it's an expensive, you know, storage media for those kinds of files. And so what we have seen across the board is that most people want a cheaper storage media like object storage for things like, you know, MPEG files. But clearly, you know, it can be done. The real question for us is, you know, do we promote NoSQL as a storage media for those large files, or is it a better approach to offer a much cheaper storage media? As you all know, one of the areas for us is competition with the other cloud providers that have really focused heavily on pricing and cost. So our current thinking is that is to focus on you know, cheaper storage solutions for those larger files, which is object storage. Did that answer your question, Matt? Yes, so it can. NoSQL can absolutely have a pointer to object storage. No problem on that one.
So if I do a write to a REST interface, I could write my image right down to object storage.
Yeah, so that's a good question. So yeah, one of the things we have on our roadmap is to do exactly as you're saying. Now, one of the challenges is that you know, there is no way to coordinate a transaction and make it an atomic operation between us and object storage. So it's one of the challenges if we offer that as an API, but it's certainly something we have thought about, and we haven't totally dismissed it yet. Okay, another question from Sachin. Do we support Cloud at Customer? Yes, we are now live at the first Cloud at Customer region, which is somewhere in Japan. I can't remember, but yes, we are currently live with the first Cloud at Customer deployment, and it is available today. So Matt, if you have further questions on that, I would love to discuss, and we could take it offline.
Well, yeah, I'm trying to see if we can use this product, you know, more along the lines of a data lake, right? Since the Oracle database, people haven't gotten their act together, the question is, can I plug in your NoSQL solution and have it transparently talk to object storage through my reads and write requests? And then I can scale out horizontally like you guys are showing us here.
Yes. Yeah, so that's, again, one of the other projects we're currently working on is integrating directly with FN, or, you know, functions as a service. And the idea there would be, you know, we would create events through the OCI event service. And when those events, and we would have an event for every DML operation in the table. So an update, delete, or insert would trigger an event, and the event listener can actually take that event and throw it into object store. It's one way to go, but we should talk further about, you know, what it means. The other thing we're actually in development on as we speak is exporting our data in Parquet format directly to object store, and then it is queryable, and it's actually running today. It's not a product yet, but it is queryable as an external table from ADW. And we have that running in the lab as we speak.
Well, when does that due out?
What is it, what?
Well, what's the time frame for that to go GA?
Yeah, so that's a good question. I hate to quote anything. It will be next year, beyond a shadow of a doubt. The question is whether it's going to be early on, like near the March timeframe or the summer timeframe. We don't have 100% clarity on that yet, but I think we will in the next, say, 4 weeks. So I'm happy to share that date with you once we have a little bit more clarity.
Okay.
Okay, anything else? Oh, thanks, Tim. NJA is the name of the Cloud Customer region in Japan.
So, okay, thanks, Dave. If someone in the meeting is interested by the demo, do not hesitate to contact us.
Absolutely. Yeah, contact myself or Dario. We are happy to discuss further. As I said before, we'll send out a pointer to the slides as well as the recording. Can we create a website version of the demo for external usage? It actually, by the way, it is available externally right now. So ndcsdemo.com is actually live in global DNS as we speak. And as Dario mentioned, there's 2 flavors of the demo. One is really the use cases for an airline employee servicing customers. And if you just go to ndcsdemo.com on your desktop, it will automatically render the airline employee user experience. And again, it's out there worldwide and available externally. And again, available externally, you guys just did it. Go to ndcsdemo.com on your phone, and that renders the consumer user experience just automatically, right? So this is just automatic, depending on what type of browser and technology you're using to get in.
And just for information, we have the authorization to use the name of the airline. So Blue Mist, it was authorized by, I don't know who, Dave?
Yeah,
and we have the authorization to use the model for the data. That is the point, Dave?
Correct. Yes. So right, the point, it's a good point, Dario. So Oracle Branding has given their blessing to use the name. And as we said, the data is, the original data came from Emirates Airlines, but this is all anonymized. It's all randomly generated. There are no names that look like any real world names. There are no contact phone numbers that look like real world phone numbers or that map to real world phone numbers. It is purely randomly generated data. So there should be no privacy concerns with any of that stuff.
So we have all authorization, and the idea of this demo is for external users. It's not for internal.
Absolutely. Okay, so if there are no other questions, I want to thank Dario for co-presenting, and of course all his hard work on the demo. Again, feel free to contact us with any questions you may have as a follow-up. And thank you all for joining. Okay. Bye.